नमस्कार, जय गुरु। स्वांतः सुखाय तुलसी रघुनाथ गाथा। ये पंक्तियां रामचरितमानस में उद्धृत हैं, जो कि गोस्वामी तुलसीदास द्वारा रचित है। इन पंक्तियों में गोस्वामी तुलसीदास जी ने अपने आत्मसंतुष्टि के कारण रामचरितमानस की रचना की, ऐसा वर्णन किया है। इस पंक्ति के माध्यम से मैं विद्यार्थियों को संकेत देना चाहता हूं कि जिस किसी व्याख्यान को आप सुने वो पूरे मन से सुने, उससे आपको प्रसन्नता का अनुभव होना चाहिए, उसमें आपको सेल्फ सेटिस्फैक्शन होना चाहिए, ताकि हमारा प्रयास और आपका अध्ययन सार्थक हो सके। मैं रितेश कुमार पाठक, डिपार्टमेंट ऑफ फिजिक्स, इंटरमीडिएट विंग ऑफ योगदा सत्संग महाविद्यालय। इस लेक्चर में आपको इंट्रोड्यूस करवाऊंगा कंटिन्यूअस चार्ज डिस्ट्रीब्यूशन टॉपिक से, जिसमें कि हम जानते हैं कि इलेक्ट्रिक चार्ज क्वांटाइज्ड होता है और मिनिमम चार्ज जो एग्जिस्ट करता है वो प्लस माइनस ई के फॉर्म में हो सकता है, जहाँ पे ई किसी एक इलेक्ट्रॉन या प्रोटॉन का चार्ज है और नंबर के फॉर्म में उसे 1.6 इंटू 10⁻⁻19 कूलम लिख सकते हैं। तो चलिए जानते हैं आगे के टॉपिक के बारे में। Before going to the depth of this topic, we should know about the concept of point charge. So we can say that any charge which covers a space with dimensions much less than its distance from an observation point can be taken as a point charge. So it is a very small entity, and why we need to work with continuous charge distributions, or what is the necessity of it? The reason is given here. It is impractical to work in terms of discrete charges. For example, on the surface of a charged conductor, it is impractical to specify the charge distribution in terms of the locations of microscopic charged constituents, as these are very small in size. So it is more feasible to consider a line element, area element, or volume element on the microscopic scale, but big enough to include a very large number of charged entities to specify the charge on that element. Means, if we are taking a wire-like structure in the form of conductor or insulating material that poses some charge, then that would be represented as line element. Later on we will see the examples also. On the other side, if we take a surface area, a plane sheet of any material having some charges, that is assumed to be an area element. While if we take like a sphere like surface which has the volume keeping the charges inside it, then that can be treated as volume element, and they contain very large number of charged entities such as electrons and positively charged particles, and that is why we need to work with continuous charge distributions, because here we see how these charges inside these elements are spread. Now we may define the continuous charge distribution as a system of closely spaced point charges forms a continuous charge distribution. Here the term closely spaced, they are very close to each other, but there must be spacing between them. The point charges, obviously. It means that distribution of discrete charges is continuous. As we already know, the charges are quantized, that means they are discrete. So the distribution of discrete charges is continuous with little space between them. This is another way to define it. Now, the three types of charge distributions are: number one, linear charge distribution; number two, surface charge distribution; and number three, volume charge distribution. So first we take linear charge distribution. When the charge is distributed along a line, which may be straight or curved, such as in case of straight line wire, or in case of the wire which has the circumference like a circle, the charge distribution in that type of element is called linear charge distribution. It is represented in terms of linear charge density, and which is denoted by lambda, a Greek letter. If we assume q, small q, with a charge distributed uniformly, that means after definite spacings, over the length L of a rod, which is a line element, then lambda may be given as q upon L, that means charge per unit length of that rod. The SI unit from this formula may be written as coulomb per meter, and the dimension will be L to the power minus 1 AT. Second, surface charge distribution. When the charge is spread over some surface of any shape, that is in two dimensions in a continuous manner, such as a charged membrane, then it is called surface charge distribution. It is represented in terms of surface charge density and denoted by sigma, which is equal to the charge q, which is spread over that surface per unit area S, and mathematically it can be given as sigma equals to q upon S. And from here we may draw the SI unit as coulomb per meter square, and dimension may be written as L to the power minus 2 AT. The third one is volume charge distribution. When charge is continuously distributed over a volume like a sphere or a cube in three dimensions uniformly, then the distribution is called volume charge distribution. It is represented in terms of volume charge density, which is denoted by rho, and equal to the charge per unit volume of that object. If we assume q with a charge distributed uniformly over the volume V of a spherical object, then rho may be given as q upon V. And from here we can draw the SI unit as coulomb per meter cube, and dimension L to the power minus 3 AT. The important thing is that the field due to a continuous charge distribution can be obtained in much the same way as for a system of discrete charges. That means there will be no complexity while finding the field for or within these charge distributions. This is all about the topic which is discussed in this lecture. If you have any doubt, please drop it in your comment box. Thank you. Jai Guru.